In video 1 of this series, we concluded that cutting and forming were the two primary operations that could be performed in a stamping die. Our topic of choice for this video is cutting. We will discuss the basics of metal cutting, the different types of cutting operations, and some of the common terms associated with metal cutting. In order to clearly understand metal cutting, we must shift our paradigm with respect to how metal really behaves when being subjected to tension or compression. Metal behaves very much like an elastomer. Think of it like silly putty. You know, the stuff that came in a red egg that you got to play with when you were a kid? Steel, when subjected to a great deal of force, behaves very much like silly putty in our hands. It's kind of a rubbery plastic. First, let's start with metal cutting basics. Cutting is perhaps the most common operation performed in a stamping die. In most cutting operations, the metal is stressed to the point of failure between two bypassing die sections or components. Let's take a look at metal cutting step by step. First, the metal cutting punch travels downward and hits the sheet metal. At this point, a great deal of shock is transferred up through the cutting punch. As the punch begins to enter into the metal, it begins to deform the metal slightly. Remember, metal is an elastomer. Imagine driving your finger into a marshmallow. The amount of deformation is a product of the metal's ductility, thickness, and the space or clearance between the mating cutting sections. As the punch continues to travel downward, it begins to push out or cold extrude the metal. Once the shear strength of the metal has been met, it begins to fracture or break away. Shear strength can be defined as the maximum strength that the metal can withstand when subjected to two bypassing planes. With the exception of specialized processes such as fine blanking, conventional cutting processes won't produce a perfectly square cut edge, but rather a smooth, small flat followed by a slightly angled, rougher surface. The rough portion of the cut edge is often referred to as breakout or the fracture zone, while the shiny, smooth portion is called the cut band or shear zone. With most conventional cutting operations, the thickness of the cut band is about 20 to 40% of the metal's thickness. This is a very important item for product designers to understand, as this angle will mean that the part will be different dimensions depending on which side of the metal you are measuring. To cut metal, the die first must have a cutting punch and a mating section into which the punch enters. The distance between these two working sections is called the cutting clearance. The distance between the cutting sections varies with respect to the metal type, thickness, hardness, and desired edge quality. The cutting clearance is often expressed as a percentage of the metal's thickness. Although cutting clearances can range from 0 to as much as 25% of the metal's thickness, the most common cutting clearance used today is around 10% of the metal's thickness. For example, if you were to design a die to cut metal that is 50 thousandths of an inch thick, the distance between the upper and lower cutting sections would be approximately 5 thousandths.